So here I am in my EC2 dashboard. You can see that there are two servers running. One has PredicSis.ai and the other has JupyterHub. The logins for both of those servers and the URLs are in your student folder. Please take them out and go to each URL and log in as I'm going to do right now. So at this point, I'm going to copy the URL to the PredicSis.ai user interface and log in. And here we are at the empty projects screen. Now I'm going to log in to the JupyterHub with the URL that's given in your student folders. And I'm going to log in here and sign in. JupyterHub is used to execute executable code like Python. We're going to use the AWS reInvent Workshop 1 Add Data and Gain First Insights IPython notebook to move data from Amazon S3 to PredicSis.ai because it's faster. Click on that, and then how you run this is you highlight each cell and click Shift Enter, and you just keep doing that until you get to the end. Now that everything's been executed, you can see that the project, Tesla project, was created. A dataset CRM was created, one for emails, one for orders, and one for visited pages. Notice that a token is required to access PredicSis.ai engine via the Python library. One has been created for you, but in case you need to create new tokens, it's done from the GUI, which I'll show you. Now go to the PredicSis.ai user interface. And here's the Tesla project that was created for us via the Python script from JupyterHub. Where you would create a token if you needed to is right here. After you click on the people icon, there's a link tokens, and that's where you would create it. PredicSis.ai uses non-parametric machine learning to run a first analysis focused on the customers list, the CRM file. While the machine is doing some science, the project status is pending in the projects page, but here it says completed. You'll notice things pending when I click on things for analysis later on in this video. So let's click on open. So I'm going to rename this something that makes more sense, like CRM Data only. Once PredicSis.ai's initial algorithm is finished and the results are in, the user can perform 4 actions: view the insights via the magnifying glass icon, improve the results with the lightning bolt icon, materialize the insights via the box with the arrow icon, and assess the predictive performance via the chart icon. Click on the magnifying glass to explore the insights the machine discovered from the data. You'll see a page similar to the one that you see on the screen. The features that contribute the most to the prediction are presented in a highest to lowest manner. Click on the different features to see how the visualizations change with each field and how the contribution changes with each field. Notice that age is a particularly interesting visualization because there's a definite age range between 30 and 34 where the odds of buying a Tesla are higher than expected. PredicSis.ai's insights are shareable, and you can add notes for different teams or people right from the browser-based UI. To add a note, click on the pencil icon and write your note. I added a note: customers from 30 to 34 are more likely to buy than the average, when more than 35-year-old customers are less likely to buy. It could be wise to have different actions based on age. Now I save it, I click the checkbox next to age, and then I would get the PDF to share with the proper teams. You can go back to the models page whenever you want to. Hover over our first analysis, CRM Data only, and click on Models List. From the Models page, in order to ask the question about grouping less than 29-year-old customers with more than 35-year-old customers, click the Improve icon, the lightning bolt. The Improve page is where users manually adjust the features that go into the predictive model for analysis. It's where the user removes features that are well known not to be interesting, or switches types from numeric to categorical and vice versa, when possible, to let the machine find different signals, or selects the data source to focus on first, such as the visited pages. Change the age drop-down from numeric to categorical numerical, which changes it from a quantitative value to a qualitative value, and then click Apply Changes. This is the pending icon that I referred to earlier. This runs a new analysis taking into account the change made. Let's click on the magnifying glass again and notice that the machine groups customers who are less than 29 with those who are more than 35, hence telling the user there's no significant difference between them when it comes to the propensity to buy a Tesla. Notice that country is the biggest contributor to the propensity to buy. Until now, the CRM data is the only data set used to discover customer profiles. PredicSis.ai can integrate with other data sources, web logs, email responses, orders made, visited pages, to uncover new patterns and enrich the profiles. PredicSis.ai performs all the work for you. Click on the lightning bolt icon of First Analysis CRM Data Only, and then enter the number of new features you want PredicSis.ai to surface. Enter the number of additional features you want PredicSis.ai to surface into the Create Smart Aggregates text box, and then click on Apply Changes. Let's add 10. Users can simultaneously ask for more by clicking again on the lightning bolt a few times and entering the new feature surfacing numbers. This time, let's add 20. Again, this time, let's add 50. This time, let's add 100. And this time, let's add 200. Let's give all of these models an intuitive name. When the jobs are done, the user sees that the performance is improved when surfacing new features from the behavioral data, even with a small number of features, like 10. However, you might reach a peak where you've surfaced all the important features, and by adding more features actually brings the performance down. To know which patterns the machine found, click the magnifying glass of 20 features, all data analysis. Note that country is still one of the most contributive features. However, a very new interesting feature is now the number of emails for each customer, which is basically performing count emails means. This is what we call an aggregate because it aggregates data from the emails sent to the individual level. Click and see the discovered patterns. You can see, for instance, that customers who were sent more than 35 emails, which is 6.14% of the base, are more likely to buy 1.42% than the average, which is 0.2%. So it might be worth having a conversation with the outbound email marketing team to share this information to understand why this segment is buying more. At the very least, without any effort, we have improved the predictive performance. Let's go back to the models list and have a deeper look at the predictive performance. We see that the more we ask PredicSis.ai to surface features, the higher the performance is until we get to a certain point. Click on the 100 features, all data to get a more detailed screen. So click on the chart icon. There's a lot of valuable information on this page. Mouse over the cumulative gain chart to get to the 20% population point. You can read the fourth row in the table on the left as well. The results read this way. If you consider 20% of the population with the highest probability to buy, the machine tells you that you can reach 95.11% of the buyers. This means that you have a way, thanks to predictive scores, to know which part of the population to address and which part not to address. Think about the impact this can have on a marketing budget. When we're here, we know what drives the buying outcome of past customers, and we have an estimation of how the prediction is effective. The business user can change some rules, like maybe targeting more people between 30 and 34, but that's one rule only. What about all of the others? And what about the current customers? Can we use PredicSis.ai to take every tiny signal discovered and make some computation against the current customer base? The answer is yes. Simply get the data related to the actual customers, a list of current customers with their age, country, etc., plus their data points collected the same way as for past customers. The structure of the data has to be the same for the machine to run. We're going to apply this to current data available on S3 and create a CSV file with the results in it. Go to the Jupyter Hub project page. Open AWS reInvent Workshop 2 Add Data from Current Customer Base Notebook. Instructions are given for the notebook. Everything has been set up for you, and you have nothing to do but run the cells one after another, just like before. This notebook moves current customer data from S3 to PredicSis.ai. When it's done running, you can see that it has created the 4 data sets from the current customer base. When done, go back to the PredicSis.ai GUI. We are going to detect early signals via the GUI. Select 50 Features All Data and click the export icon. Click on Create Your First Export to configure the output that you need. Check the Current Customers checkbox to tell PredicSis.ai to compute against the data that we just got from S3. Click Add Native Features and select the following. If you don't see it in the first page, so that you don't have to paginate, you can just start typing it in the search box. So we want first name, last name, country, age, flag car owner, flag boat owner, flag home owner, flag jewelry buyer. After you've selected all of them, click Validate. Click Add Aggregates and select Count Emails and Count Orders. And again, there were a lot of pages there, so it's much easier to use the search box. When you're done, click Validate. Click the Export button. We can give this an intuitive name, like Current Customers Scores, and then we click on the cloud icon to download a text file full of predictive scores regarding the current customer base. We will visualize the data that we just produced with TIBCO Spotfire in the next demo.